Here, welcome to Gyanmurti channel. Dear friends, today we will talk about general methods of preparation of alcohols. Hello friends, welcome to Gyanmurti channel. Today we will discuss about general methods of preparation of alcohols. Dear friends, monohydrate alcohols can be prepared by the following methods. One is from haloalkanes. As we know, haloalkanes, when heated with aqueous alkali or moist silver oxide, the corresponding monohydrate alcohols is obtained. And we have a visualization of example here and general formula also, that is Rx, that is haloalkane, plus KOS, that is potassium hydroxide in aqueous form when heated, that is alkali when heated, it gives alcohol, that is ROH, plus KX, that is potassium halide. Similarly, we have iodoethane, a chemical compound, that is haloalkanes, when treated with aqueous alkali KOH, it gives ethanol C2H5OH plus potassium iodide Ki. Similarly, bromoethane, on treating with moist silver oxide, that is AgOH, it gives ethanol, because here is the displacement reaction takes place as the positive part of Ag plus combine with negative part of bromoethane, that is Br, and form AgBr, which is solid silver bromide, and ethanol are obtained. As mild alkali such as HgOH gives better results for the preparation. Similarly, we have primary haloalkanes gives good yields. While secondary haloalkanes mostly give alkenes, and tertiary primary haloalkanes give good yields. Tertiary haloalkanes mostly give alkenes. Secondary haloalkanes give a mixture of alcohol and alkanes. Similarly, we have by reduction of carbonyl compounds. It is another general methods of preparation of alcohols. Here, carbonyl compounds like aldehydes, ketones, carboxylic acids, and acid derivatives can be reduced to alcohols. Here, reduction reaction takes place, and reduction can be carried out by using hydrogen gas in the presence of catalyst such as nickel catalyst, platinum catalyst, or palladium catalyst, or lithium aluminum hydride, that is LiAlS4, or sodium borohydride, that is NaBH4. Here we have example visualization. Here it is clear that CH3COCl, that is acetyl chloride, is a carbonyl compound. While treating with hydrogen, that is in the presence of nickel catalyst, and using hydrogen gas, there is two molecules of hydrogen present in this reaction to form ethanol, as there is chlorine and another we have a carbonyl compound, so oxygen must have to combine with a nascent hydrogen to form hydroxyl group, and another hydrogen must combine with chlorine to form HCl, that is hydrogen chloride, in the presence of catalyst nickel. Similarly, CH3CH2, that is acetaldehyde, that is ethanol. Ethanol, when treated with hydrogen in the presence of nickel catalyst, it forms ethanol, that is ethyl alcohol. It is a simple reaction we can visualize easily. Similarly, we have given in the figure here an illustration that propanone is a acetone, and when it is treated with hydrogen gas in the presence of nickel catalyst, it form 2-propanol or alcohol compound. Similarly, on the reduction of aldehydes gives primary alcohols, that is 1-degree alcohols, while ketones gives 2-degree alcohols. Ester on reduction gives alcohols, and their byproducts are also alcohols. Here we have RCOO R prime. It may be same as that of R, that is alkyl group, or may be different than alkyl group. When treated with 4 nascent hydrogen, it forms RCH2OH, that is a alcohol, and another R-OH also form alcohol. Similarly, we have example methyl acetate, that is ester, and treating with hydrogen it forms ethyl alcohol and methyl alcohol. Both alcohols are obtained. Another we have from Grignard's reagent, we can treat Grignard's reagent forms addition products with aldehydes and ketones. While on treating with aldehydes and ketones to Grignard's reagent, that is carbonyl compounds, when treated with Grignard's reagent, it forms an addition product, and which on hydrolysis with water in the presence of acid, that is HCl, it gives further an alcohol, which and a byproduct also given by this chemical compound, that is Grignard's reagent. We have given here clearly that carbonyl compound on treating with Grignard's reagent RGMX, it gives addition products RCOMGX. On hydrolysis in presence of HCl with water, it gives RCOH, that is alcohol, plus MgOHX. The reaction can be used to produce different types of alcohols. Similarly, we have for primary alcohol, Grignard's reagent for Grignard's reagent with formaldehyde, that is methanol, gives primary alcohol. Here, that is HCHO, that is methanol, on treating with RGMX in presence of ether, it gives addition product, and further on hydrolysis in presence of water and acid, it gives primary alcohol and an additional product also. Here example is given that formaldehyde, that is methanol, on treating with CH3MgBr, it gives addition product, and which on hydrolysis gives ethanol, that is ethyl alcohol or primary alcohol. Similarly, Secondary alcohol, that is all aldehydes except formaldehyde, gives secondary alcohol with Grignard's reagent. And we have example here: ethanol on treating with Grignard's reagent, that is acetaldehyde on treating with Grignard's reagent in presence of ether, it gives addition product, that is given, and finally on hydrolysis it gives additional product along with 2-propanol, that is one that is alcohol, that is secondary alcohol, isopropyl alcohol or secondary alcohol is formed, as we can see here. Similarly, we have tertiary alcohol. Ketones with Grignard's reagent give tertiary alcohols. For example, acetone propanone gives tertiary butyl alcohol, as we have in a chemical reaction given here. Propanone is treated with CS3-MgI, that is Grignard's reagent, that is tertiary alcohol is formed by when treated with in presence of ether. Grignard's reagent with propanone, that is acetone, it gives additional product, and finally on hydrolysis with water it gives additional product and 2-methyl 2-propanol tertiary butyl alcohol is given. Similarly, from primary amines, as we know, primary amines when treated with nitrous acid, that is HNO2, it gives primary alcohols. Ethylamine gives ethanol, as we have the formula of amine, that is NH2 is its functional group, as we know, and C2H5 is ethyl group. So ethylamine on treating with HNO2, that is nitrous acid, HONO compound, it gives the ethanol on releasing nitrogen gas and water itself. Similarly, N-propylamine on treating with nitrous acid, it gives N-propyl alcohol, including giving the release of nitrogen gas and water H2O. Similarly, in the case of methylamine, where methyl nitrite is produced instead of methyl alcohol, it is a condition we have to take in mind, that methyl nitrite is produced instead of methyl alcohol on treating with nitrous acid of methylamine, and it is the exceptional case. Similarly, from esters on hydrolysis in the presence of mineral acids or alkalis gives alcohols. Here we have esters, that is RCOOR dash plus water H2O in presence of acid, that is mineral acids, and certain temperature condition, it gives carboxylic acid and alcohols, that is RCOOH plus R dash OH. Here is given methyl ethanoate or methyl acetate on treating with water in presence of mineral acids, it gives ethanoic acid, acetic acid plus methanol, that is methyl alcohol. Also, we have industrial preparation of alcohols. Here, alcohols are obtained in the industrial scale by the different methods. First one is hydration of alkenes, as alkenes converted into alcohols by the method, that is, first one is direct addition of water, as alkenes are converted into alcohols by direct addition of water in the presence of phosphoric acid, that is S3PO4. That here we have example given in the figure. Here a chemical reaction is representing 2-methyl 1-butene, that is isobutylene, is given with treating with water in presence of phosphoric acid, that is direct addition of water takes place here in presence of phosphoric acid. Here 2-methyl 2-propanol is obtained, as the bond is here dissociated and OH group goes to attach to the carbon atom, which forms carbon-carbon double bond and form tertiary butyl alcohol here. Similarly, by indirect method of hydration is the next type of method, that is hydration of alkenes for industrial preparation of alcohols. Alkenes, when treated with concentrated sulfuric acid, the product is hydrolyzed with water and alcohols are obtained. Here first we have to know that alkenes are treated with concentrated sulfuric acid H2SO4. The product is hydrolyzed with water, then it is hydrolyzed, that is hydrolysis takes place, and after alcohols are obtained. Ethanol is the only primary alcohol which is obtained by this method. This method is suitable for preparing secondary and tertiary alcohols. Ethene gives ethanol by this method, while higher alkenes give secondary or tertiary alcohols. Ethene, on treated with concentrated sulfuric acid, it gives ethyl hydrogen sulfate, and on hydrolysis it gives ethanol plus sulfuric acid, a primary compound. Here HSO4 combined with hydrogen of water and OH of water is attached to the alkyl group to form ethanol and alcohol and sulfuric acid. Similarly, propene gives a secondary alcohol, that is 2-propanol. Here propene, on treated with sulfuric acid, it gives additional product, that is propyl hydrogen sulfate, and which on further hydrolysis treating with water, it gives alcohol, that is 2-propanol isopropyl alcohol, 2-degree alcohol, and sulfuric acid. Addition of sulfuric acid to unsymmetrical alkanes means those alkenes, unsymmetrical alkenes, that is those alkenes whose are unsymmetrical, means there is the different alkyls groups are present, or in that alkenes takes place according to the Markovnikov's rule, that is Markovnikov's rule is applied to unsymmetrical alkenes in the addition of sulfuric acid. And another we have by oxo process, alkenes react with carbon monoxide and hydrogen. Alkene reacts with carbon monoxide and hydrogen that is water gas, in the presence of cobalt carbonyl, that is CO4 2, at high temperature and pressure to yield aldehydes, and catalytic hydrogenation of aldehyde gives primary alcohols. Here we have to know that ethene, when treated with water gas, that is carbon monoxide and hydrogen, in presence of cobalt carbonyl catalyst, it forms a additional product, that is propanol, propa, pro, uh, propanol, that is propionaldehyde, pro, propionaldehyde, and in presence of nickel catalyst, that is hydrogenation, in treating with hydrogen in presence of nickel catalyst, as of first chemical reaction, treating with hydrogen in reduction reaction, that is general methods of preparation of alcohols. The rear part is same as that of general methods of preparation in oxo process, and we have to consider here that we have to only remember here that the ethene is treated with water gas, that is carbon monoxide and hydrogen, in presence of cobalt carbonyl compound, that is catalyst, and it forms propionaldehyde, that is aldehyde is formed, and aldehyde on treating with hydrogen in presence of nickel, it gives alcohol, as we have already known in reduction of carbonyl compounds. Reduction takes place here to form one propanol. We have chemical reaction. Similarly, we have final industrial method of preparation of alcohols. We have by fermentation of carbohydrates. As we know, slow decomposition of large organic molecules into simpler ones in the presence of enzymes is known as fermentation, and a fermentation process is most very oldest method of preparation of ethanol from carbohydrates, that is sugar or starch, in the presence of suitable enzymes like zymes. Fermentation of glucose gives ethanol. Here we have chemical reaction, that is C6H12O6, that is formula of glucose, that is it is glucose found treated in presence of zymes yeast, that is fermentation takes place, and it gives 2C2H5OH, that is ethanol plus carbon dioxide is released. Thanks for watching this video. Please like, subscribe, comments and share. If you have any query, please you can put into comment section. You can ask any types of these problems which you have created in this video lecture. Have a nice day, stay healthy, stay safe. Thank you.